Hi, everyone, and welcome back to Calendar Math with Mrs. Udoh. I'm so glad you're joining me today. Do you know what month it is? Let's think. Well, remember, it's the fifth month of the year. And not only is it the fifth month of the year, it is the month that comes after April, but before June. And so what does that mean? Let's think. If it is the fifth month of the year and the month that comes after April but before June, then it must be May. Great job, guys. Do you know what today is? Some people call it Hump Day. Does that help you figure it out? Today is Wednesday. And if today is Wednesday, then what was yesterday? Did you say Tuesday? That's right. Yesterday was Tuesday. And if yesterday was Tuesday and today is Wednesday, what will tomorrow be? You guessed it, tomorrow will be Thursday. Let's take a look at our calendar. Remember, the calendar assigns one number to every day of a month. Let's count together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. What comes after 19? Well, we are at the very end of the teen numbers. So if we were looking at a hundreds chart, we'd have to get ready to prepare to shift on over to the next row because we are at the end. And so what number is at the end of that hundreds chart before we prepare to shift over? Did you say 20? That's right. Today is the 20th day of the month of May. So let's say our date together. Today is Wednesday, May 20th, 2020. Remember, when we say the date, we start with the day of the week, and then we say the month, the date, and then the year. Let's try it one more time. Today is Wednesday, May 20th, 2020. Great job. All right, littles, here's your problem. Remember, all this week, you guys have been working in Mrs. Udoh's candy shop. What do you remember about Mrs. Udoh's candy shop? Do you remember this picture? Well, what does it represent? That's right, it represents a box of candy. And how many candies come in a box? Did you say 10? That's right. When Mrs. Udoh sells candy in her candy shop, a box always has 10 candies. Now, what about this? Do you remember what this represents? That's right. This is a piece of candy. And we get pieces of candy when we need something that is less than 10. So I've added something on our candy shop chart today. All week we've been talking about boxes and pieces, but today I want you to understand that if we're discussing place value, our boxes represent tens because remember, a box of candy has 10 pieces, and our individual pieces, they represent our ones. So let's begin with our order. Today's order says 27 candies. Wow, well, this order looks a little different than the ones we had on Monday and Tuesday. It didn't tell you how many boxes and pieces. We have to figure that out for ourselves. Well, first, in order to figure that out, we need to know how many boxes and how many pieces, or how many tens and how many ones are represented by the number 27. Well, check out this easy way to figure that out. I'm going to take the number 27 and I am just going to split it right down the middle and put the 2 on my boxes side and the 7 on my pieces side. And that is because the number in the front represents our tens and the number in the back represents our ones. Therefore, we know that we are going to need 2 boxes to make our number, and then we're going to need That's right, 7 pieces. 1, 2, 3, 4, 5, 6, 7. Great job. So now we just have to do a quick count and check our work. So remember, the 2 boxes are 2 tens. So how many candies are on the boxes side? Remember, if we're on the boxes side, we can count by 10. Let's do that. 10, 20. Great job. Now, when we're ready to count our pieces, we start with the next number after 20. 21, 22, 23, 24, 25, 26, 27. Now we know that we have correctly represented 27 candies. We also know that 2 boxes is also 2 tens or 20 candies. And then 7 pieces is also 7 ones. And when we put them together, we get 27 candies. Great job, littles. All right, middles, here's your problem today. It says find 2 fractions that are equivalent to 1/4. Well, remember, all week we've been talking about fraction strips. So we're using visual models to represent our fractions. And we've had one word that stuck out all week. Do you remember what it is? That's right, it's the word equivalent. And what does it mean to be equivalent? That's right, equivalent means equal or the same. And when we look at our fraction strips, we want them all to line up, and that's what we're going to use our dotted line here for. And so the fraction that we're representing today is 1/4. So we are going to look at 1/4 on our side of our fraction strips. Now, here's our 1/4. And yesterday, I taught you guys a strategy for figuring out how to find fractions that are equivalent to 1/4. Does anyone remember what it was? That's right. We can find fractions equivalent to 1/4 by looking at the multiples of 4. Remember, multiples are the answers or the product that you get when you multiply 4 times 1, 4 times 2, 4 times 3, 4 times 4, and so on and so forth. So let's do that together. Can someone tell me what the first 4 multiples of 4 are? Did you say 4, 8, 12, and 16? If you did, you're absolutely correct. Well, now that we know what the multiples of 4 are, how can we use this to help us out? That's right. The multiples become our denominators. So they are going to tell us which fraction strips we're going to select. And so since 1/4 was our first number, we've already used 4 as a denominator. So which one is next? That's right, it's 8. And so we're going to use the 8th strips. So we need to determine how many 8s will make something that is equivalent to 1/4. And we know that they're equivalent when our bars line up perfectly. So let's count. 1/8, 2/8. Looks like our bars are in line. This tells us that 1/4 is equivalent to 2/8. All right, you try the next one. Well, what was our next multiple of 4? That's right, it was 12. So that tells us that the denominator of our next fraction will be 12. Which fraction strip should we use? That's right, we're going to use the 12 pieces. And we need to figure out how many of them we need in order to get a bar that is the exact same length as our 4th and our 2/8. Let's count. 1/12, 2/12, 3/12. This tells us that 3/12 is equivalent to 1/4 and 2/8. Now, I only asked you to identify 2 equivalent fractions, but I bet you can tell me what the 4th one is as well. To start, how do we know what fraction strip we should use? Did you say we're going to use 16? You're absolutely correct. And so if we use the 16ths as our next strip, Do you have a way to tell me what our next equivalent fraction is based on the pattern? Let me circle the numerators and see if it helps you out. Take a look. Do you see a pattern between the numerators? Did you notice that the numerator of the first fraction was 1, the second was 2, and the third was 3? And so what do you think the numerator of the next equivalent fraction will be? That's right, it should be 4, and the denominator should be 16. So let's see if we pull 4/16, if it will give us a set of tiles that are equivalent to 1/4, 2/8, and 3/12. Oh wow, it absolutely does. Great job, middles. You did a phenomenal job today. All right, senior scholars, here's your problem of the day. So all week we have been multiplying a double-digit number by a single-digit number. So today we're going to up the ante and we're going to multiply a double-digit number by a double-digit number. But we are still going to utilize our area model. So remember, when we're multiplying using the area model, we always start by writing both of our numbers in expanded form. And because we now have two double-digit numbers, we have to expand them both. So let's start with 25. What is the number 25 if you write it in expanded form? Did you say 20 plus 5? If you did, you're absolutely correct. Well, what about the number 15? How do we expand it? That's right, 10 plus 5. And if you recall, we always create a box in order to do our work in for our partial products. As you can see, my box is a little larger this time, and it's because I need to have an area to multiply each of my numbers. So let's begin. First, we're going to multiply 10 times 20, and it's going to go in this box right here. So 10 times 20 is 200. Now, what do you think I'm going to multiply next? Did you say 10 times 5? If you did, you're absolutely right. Well, what is 10 times 5? Did you get 50? Great job. What do you think is going to happen next? Did anyone say multiply 5 times 20? Great job. 5 times 20 is 100. What do you think is going to go in that last box? That's right, 5 times 5. I like to think of it as the numbers that would run into each other and fall in a place. And that tells me which box we're going to be multiplying in. So 5 times 5 is 25. And so what I've highlighted for you are our partial products, because we took our problem and we broke it into pieces. And so now these are the individual small products that we came up with. What do you think we're going to do with these four numbers? Did anyone say add them together? If you did, you're absolutely correct. So we are going to add 20 plus 100 plus 50 plus 25. And when we do that, what do we get? Did you get 375? If you did, you're absolutely correct. Therefore, 25 times 15 equals 375. Great job, senior scholars. We'll do one more problem just like this tomorrow to prepare you for Challenge Day. Well, thank you so much for tuning in to Calendar Time with Miss Whitfield. Miss Udoh. I will see you tomorrow. Bye-bye.